All right, so today we are going to be going through 3.5. This should be our last new section before we're going to be testing on this stuff for this chapter. Um, going to be revisiting a little bit of input, output, and function notation here. And basically, it's just a lot of analyzing graphs is all today's going to be, and your analysis assignment as well. So the input, we've talked about this a little bit. So the input is essentially what you're plugging in kind of normal terms there. And so we're plugging into that equation or a function in order to see what comes out of it. Okay, so that input, and I'm going to kind of refer to the function notation in some of this stuff. That input, like if we see f of 4, that 4 is your input. Okay, so that's the number that we are plugging in for those variables. Your input in terms of an ordered pair is also your x value typically. So you'll see when we have those equations of the basic example we can talk about is y equals mx plus b, where y is by itself, we plug something in for x. That's what you're plugging in. You're picking that x value to plug in and then see what comes out for the y to create that ordered pair. Okay? And then the output is kind of your result. When we plug something into that equation, the output is what comes out of it. Okay? So it's kind of like a little machine. You throw something in the machine, you let it do its job, and then it spits something out at the end that it made for us. That's going to be the result of what that function did to that value we plugged in. So that output is your result from plugging something in. In function notation, we have that f of x. So if we were to see that f of 4 ended up equaling 13, okay, we plugged 4 in and 13 came out, that 13 is your output. All right. And then again, in terms of an ordered pair or a function setting, that output is typically your y value in the cases that we're going to be dealing with it. Okay. And then function notation, I've been using it here, but again, don't let function notation scare you or let you think that something crazy is going on. We see function notation quite a bit moving forward here. Okay. So when we're used to seeing like y equals mx plus b, this function notation now, that would be rewritten as f of x equals mx plus b. Okay, and remember, we talked about this at the start of the chapter. If I were to read that from left to right, this f of x, what that says is function f in terms of x. So f is just like the name of the function. The x in parentheses, that we're just saying that that is the variable that's holding the place of the unknown. Okay, so you could have something like g of x is equal to 3x minus 5. Okay, so then if they tell you that your x is equal to 4, you're going to plug that in for x, so that would be your input. Okay, so now your g of 4 would be equal to 3 times 4 minus 5. They're just telling you to replace the x with 4. They're just saying when x equals 4, find out what comes out of that equation. Okay, so one of the big mistakes that we end up seeing a lot, or misunderstandings, is that people think this has something to do with g times 4, because that's, we're used to seeing multiplication like that, some number outside of parentheses. I understand that confusion. That's not what's happening. Okay? So this is not G times 4. Okay? It is function G in terms of 4. So we're plugging 4 in as our input. Okay? And then, what is 3 times 4 minus 5? What's that going to be? 7. So 3 times 4 is 12, minus 5 is 7. So what you're going to end up seeing then, so G of 4 equals 7. That 7 is your output. That's that input-output conversation. So the input is what you're plugging in, like we said, and the output is what the result is from plugging in that 4. Okay? So then this is basically giving you your ordered pair again. So we plugged in 4 for X, and we got 7 as that output for the Y. Even though there is no Y, the Y represents your output. It's the result of plugging in X. So this is kind of a lot to look at here, but function notation isn't anything different as far as how it operates. It's just a different way of expressing what you're plugging in. Okay? So you got that G of X statement. We were told X equals 4, so we plugged in 4 for G of 4. We plugged it in the equation for X. We found out that that ended up coming out to be 7. So your G of 4 is equal to 7. Function G in terms of 4 is equal to 7. That makes your ordered pair of 4, 7. Right? So nothing different is happening. It's all the same as if this were just a Y. Okay. So now the actual examples happening today. The graph of a function h. So again here, this is like its name, right? Function h is shown below. Find h of 2. Well, remember that h of 2, that's like your h of x statement. So they're telling you that x is equal to 2 right now. So what they're asking for on this example is, judging by our graph of our function, that blue graph, where are all the places in terms of y that x is equal to 2? So kind of the way that this would be worded, when x equals 2, excuse me, what are my y values? That's kind of the question this is asking. So when x equals 2, what are my y values? So your x is equal to 2 right here. So you're looking at all the places where x is equal to 2. X is equal to 2 on that vertical line going through 2 on the x-axis. These are all the different places x is equal to 2. You okay with that? That purple line? So in terms of this blue graph, where on the graph, what y value on the graph does x equal to? What's the y value right here? Huh? 0. So h of 2 is equal to 0 in terms of that blue graph. So the only spot that has an x value of 2 on this graph is when y equals 0, right at that x-axis. Do we see where that's happening? How that 0 comes to be? Okay, we have another one. So now g of negative 6. Okay, so again, they're telling you that x is equal to negative 6. So where, how did I word it last time? When x is equal to negative 6, what is my y value? I suppose I could add in the thought of the graphed function. So when we have x of negative 6, okay, these are all the different values where x is equal to negative 6. What's your y value on the graph when x is equal to negative 6? So that actually ends up being 0 as well. Okay? If I have this graph, let's just add a different example in here. Okay? So for this one, if I want to know if this is going to be function m, if I want to know what m of 3 is. So I'm looking at my x value of 3. What's the function on the graph when x equals 3? What's the y value? So I just added this one in there. What's my y value at x equals 3? 5, right? So when x is equal to 3, function m at 3 is going to be at 5 on the y-axis. Okay? So that's how we're finding these values. All right. These questions. These ones are always the trickiest, the way that they're worded. They're not super easy to understand what you're being asked. So we're going to kind of rephrase these. Now, part B on this one, we've kind of seen a few times already. Okay? So let's do part B first. So that's just asking at negative 2. So h of negative 2. So h of negative 2. We are looking, so that h of negative 2 is what we've been talking about, okay? So that is when x equals negative 2, what's my graph doing at h? It's at 2, right? So h of negative 2 is equal to 2 because at negative 2 on the x-axis, the graph is up at 2 on the y-axis. That's that ordered pair negative 2, 2. Now this other question, one value of x for which h of x equals 4, that's kind of asking you the reverse question. So they're saying, which value of x is negative 4 a solution? So where do we see on our graph that y is equaling 4? At the x value of negative 3. Okay, so we have another example for that to see too. We can kind of reword these questions one more time.